Hello, this is Tim, and for this particular lesson I'm going to be going over one-step equations. So for those of you that are in my Google Classroom, hopefully you've read the slides and you have at least a working understanding of what we're about to do here, and this is more just clarification. I'm still going to go over and review some of the basics here. So for starters, these are in fact equations, and you can tell that by the fact that they all have equal signs. Equations always have equal signs. An expression does not. So you can tell by that right off the bat. You will also notice that there is a mix of adding, subtracting, multiplying, and dividing. I plan on going over all 4 operations. Some have negatives and some do not. In this particular case, I did not put fractions on here. That will be a different lesson. These are all whole numbers. So, to review, when you are trying to solve a one-step equation, or any equation really, like this, our goal is to ultimately figure out what the letter, also known as the variable, is equal to. Now in this case, I used x for all of my equations. X is not the only number you're going to use. They could use realistically anything. Y, Q, they could use a box, they could use a diamond, $, whatever. Realistically, on these problems, they can use anything, any sort of letter or symbol. More than likely, you're going to see a letter, and that letter will be chosen based off of the specific situation. However, X is probably the most common one you're going to see, so that's the one I used for all these. But just keep in mind that X is not the only number that you're going to see in any kind of equation. So our goal here, ultimately, again, is to figure out what the variable is equal to. Now, there are several ways to do this. And in some cases, you may be able to figure these out in your head. These problems are not super complicated. That being said, when we get to further more complex problems, or when we get to problems that have more than one step, it is important to know how to do the individual steps, because otherwise, when you have more than one step, it's going to make it much more difficult for you. Kind of like the same way, if you don't know you're adding or subtracting or multiplying and dividing, these problems will be difficult for you. So really, again, we're just kind of working on some of the starting points so that when we get to the harder stuff, you'll be able to solve them. Also, keep in mind that the equations aren't always going to look like this. They could be written out in word problems, which is very common. Again, you may get more than one step. However, the basic overall methodology does not change from question to question, and that's key. You don't know what kind of problem you're going to get. But hopefully by the end of this, you will know how to solve it. So let's start with my 2 problems up here. I have 2 adding problems. I have one here, and I have one here. So again, our goal ultimately is to get that letter by itself, or that variable by itself on one side of the equation, and a number by itself on the other side of the equation. So we're looking for x equals something. Now, again, some of you may be able to tell that, hey, Tim, I know that x is equal to 8 because 8 plus 2 is equal to 10. And that's fine. That's okay, too. But if and when we are to write this out, there is a quick, rather common way to solve this kind of problem, and that is to eliminate any number that's next to our letter. In this case, the number happens to be a plus 2. Now, this plus 2 is also known as a constant. Again, I'm going to get into more of that as we go down and get into different kind of problems. But again, this 2 is by itself and is attached with a plus. So, if we are trying to get rid of something, the easiest way to do it is to do the opposite. So the opposite of plus 2 would be a minus 2. Now, I am writing these vertically. Again, there's multiple ways to write these. This is just what I found to be the easiest way for people to visualize these kind of problems. Because normally, when you write an adding or multiplying or subtracting problem, you'll write it one over the top of the other. Now, this is an equation. And again, I know I've said that a couple times, but I just need to make sure that that is in your head. And that's important because in an equation, both sides have to remain equal. Think of it kind of like a balance. If you were to take something off of one side of a balance and not replace it on the other side, your balance will eventually become lopsided. And we don't want that. We don't want this equation lopsided. We want this equation equal, hence the equal sign, hence the term equation. So if I do something to one side, I have to do it to the other side. Now in this case, I happen to subtract 2 on one side. And again, this is going to just cancel it out because 2 minus 2 is just 0. So it's gone now. That's what we're looking for. On this side, however, I also have to subtract 2. Alright. I'll draw a little line here. Now I didn't do anything with this x. So what I'm going to do is I'm just going to bring this x straight down. Didn't touch it yet. Okay, now again, this 2 minus 2 is going to be 0. I don't need to write down 0 because 0 doesn't really do anything for us. I'm going to bring down my equal sign. And then I'm going to do my final part of the math here. 10 minus 2, which is equal to 8. And that's our answer, 8. Again, as you may have known already. So again, all we did here was we eliminated everything attached to the x. In this case, it happened to be a plus 2. And when we did it to one side, we also have to do it to the other side. So we subtracted 2 here, and we subtracted 2 here. Now, I'm going to jump over to this next problem here. Now, you'll note that the 4 is first as opposed to having the 2 being second here. Now, regardless of what side the 4 or your number and your variable is, the rules don't change. Now, hopefully you can remember back to our integer rules. If there is no sign in front of a letter or a number, you're assuming that it's positive. So in this case, this 4 is a positive 4. Now, if you remember, another way of writing positive 4 is to have a plus in front of it. So as we saw previously with the other question, the easiest way to solve this is to get rid of your number attached to your letter. In this case, it's a plus 4. And I'm going to get rid of a plus 4 using minus 4. So again, like before, that's going to cancel out on this side. And I'm going to go over here and do this thing on this side, just like mentioned. Draw my line here. My x comes down because I didn't touch it. My equal sign comes down because again, I didn't touch that. And then 15 minus 4 is equal to 11. So that is the answer to that problem. So again, even though the 4 was first in the equation, I still solved this the same way. So now I'm going to do on this next problem. This next problem is a subtraction problem. So a minus 12, what's the opposite of minus 12? Well, it's going to be a plus 12. So again, I'm going to try to get rid of this on this side because it's attached to our x. We want our x by itself. And negative 12 plus 12, hopefully remember from our integer problem, is just 0. So again, it cancels it out. Now, once again, if I add 12 to this side, I also have to add 12 to this side. Draw my line here. Again, bring my x down, bring my equal sign down, and then 19 minus 12 is going to give us our answer of 31. Now over here, again, this looks like an adding problem, but I did put the negative 7 on the other side, so it's very similar to the problem you had up top. Now in this particular case, I know that 7 is negative, so again, how would I get rid of a negative 7? I would use positive 7. And again, that's going to cancel out to 0. And again, if I add 7 to one side, I have to add 7 to the other side. Now, you might, if you remember our fraction lesson, very similar to that. So remember with fractions, when you were reducing a fraction, if you divided the numerator by one thing, you had to divide the denominator by the same number. Same kind of concept here. Again, whatever you do to one side of an equation, you have to the other side. And I'm going to keep reminding you of that because it's a very important point. It's a key point when you're solving these kind of problems or really any kind of equation problem. Now down here, I have a multiplication problem. So again, just to review, they are not going to use the x or the dot for multiplication pretty much at all when it comes to these kind of problems. They are pretty much going to put two things next to each other like this. In this case, so this is equal to 3 times x. Now, it's a little more complicated, but what is the opposite of multiplying something? It is dividing. So if I'm trying to eliminate a multiply or a times 3, I am going to divide by 3. And again, if I do something one side, do the other side. So I'm also divide this 9 by 3. Now, you might be saying, hey, Tim, this is not making 3 equal to 0, because 3 divided by 3 is equal to 1, which is correct. Technically, this is having 1x. However, as you're probably aware, 1 times anything is simply itself. So 1x is the same as having just x. they are never going to put a 1 in front as a coefficient in front of a letter. It's a redundancy. There's no point in it. Because again, 1 times anything is just itself. So 1 times x is the same as x. So in getting it equal to 1, we are ultimately just getting rid of it. So I'll show you more examples as we go along. But keep in mind that again, we're not making this x equal to this coefficient equal 0. We're making this coefficient equal to 1. Because again, 1 times anything is just itself. So that means that 1 times x is equal to just x, which is what we're looking for. You'll also note that I wrote that division kind of like a fraction. And as I stated before in the fraction lessons, division is just a fraction problem, just another way of writing it. And again, as you get further into the algebraic equations and whatnot, they're not going to use the division side. They're not going to use this guy, and they're not going to use this guy, okay? They're going to write these problems like fractions. It's easier to read, it's more compact, you can fit more problems or more areas in a certain problem. So from almost exclusively in the algebra, they are not going to use the division symbol, the time symbol, the dot, the division bar. They're going to write multiplication as two things touching, and division as a fraction. So, anyway, back to the problem. Again, my x now by itself, well, technically there's a 1 in front of it, but we don't need to worry about the 1. Again, I'll bring my equal sign down, and now 9 divided by 3 is going to give me 3. So in this case, my answer is, or my x is equal to 3. Now, same thing over here. I have a times negative 12. Now, when we solve these, we do not want a negative letter. Okay, we don't want negative x or negative q or negative box, okay? We want just a solid, positive letter or a symbol next to it. So in this case, in order to get rid of a times negative 12, I need to divide by a negative 12. Now, if you remember your division rules, a division of integer rules, a negative divided by negative will give me a positive. So negative 12 divided by negative 12 will give me positive 1. Which is just equal to 1. And that, again, will cancel out and give me my x by itself. Now, again, I have to divide this side by negative 12. Now, a lot of you may know that 144 divided by 12 is equal to 12, but you need to be careful with problems like these because this is not just a 12, this is a negative 12. So in this particular case, we have a positive 144 divided by a negative 12. And when you divide a positive by a negative, your answer is going to become negative. Remember, when it comes to multiplying and dividing sign numbers, the rules are if you have the same sign, it's a positive answer. If you have the different signs, it's a negative answer. And in this case, these two both have different signs. Hence my answer being negative. Now I'm going to go down these last two here. They are division problems. You will note, again, I wrote them similar to fractions. So this problem is actually x divided by 5 is equal to 25. Now once again, I am going to solve this by using the opposite of what they're giving me. In this case, they're giving me a divided by 5. So the opposite of divided by 5 will be times 5. Now once again, that's not going to just get rid of it. What it's going to do is it's going to cancel it out and make it equal to 1. So again, this is going to give me technically x over 1. Now, as with multiplication, anytime you divide something by 1, you're going to get the same number. So 2 divided by 1 is just 2. Again, you may remember that from our fraction problems. So what that means is that x divided by 1 is just x, which again is what we are looking for. Now, you'll also note that I said previously that they're not going to use dots or time symbols. That's exclusively in the problem itself. If you want to solve it using those symbols, that's okay. But in terms of what you're going to see on testing, they really aren't going to use the X or the dot or the division symbol or the division bar in order to solve things. Now, back to the problem. Again, that's going to cancel out. It's going to be just 5. Or x, sorry. And I also have to multiply this side by 5. And then 25 times 5 is equal to 125. So my answer in this case is 125. Now my last problem here, I have a 10. So again, the opposite of divided by 10 is multiplied by 10. Once again, that will cancel those two out, which leaves me my x by itself and my equal sign. But since I divided one side by 10, I also have to multiply the other side by 10. Sorry, multiply both sides by 10, not divide. And then 70 times 10 is 700, which is my answer. So again, all I really did with these was I took the operation they were giving me and I was doing the opposites. Another way of thinking about it is they gave us the answer, we're looking for part of the problem. Either way, ultimately what we are doing is, again, we are trying to isolate that x on one side and isolate a number by itself on the other side using the opposite operation of they're giving us. Now, some of you may want to check these, which is okay. All you have to do is you just have to plug in your answer and replace it for x. This may be similar to what you tried previously with some of the other slides. So in this particular case, I'm just going to use this one for my example. So what I solved was I figured out that x was equal to 3. So what I'm going to do is I'm going to replace that x with a 3. Now again, I know two things touching is multiplication, so this would be the same as having this. And what you got to ask yourself is 3 times 3 equal to 9? And it is. So if when you plug in, replace your variable with the number that you got as an answer, you should come out with the problem being equal. So if I knew that if I came out with like a 2, so if I came out with this, I know that's wrong because it doesn't work because 3 times 2 is not 9. So again, if you wanted to check these, replace your x with the number that you got for an answer and see does it work or does it not. If it works, great, then you're right. If it doesn't, then you did something wrong somewhere and have to retry it again. Now, there is going to be more practice on the next slide if you're my students in my Google Classroom. Either way, I hope that this helped out a little bit. I know I went through quite a bit right there, but I was trying to cover a lot of it in one video. And hopefully a lot of you notice, once you get the hang of what to do and when to do it, the math itself is not particularly difficult. Most of you, if not all of you, could do 10 minus 2 in your head with no problem. If I just said, what's 10 minus 2, you're going to tell me 8, and 9 out of 10 times is going to be almost automatic. Same thing with something like this. If I say, hey, what's 19 plus 12, most of you can come up with 31 without too many problems. So the math itself in this, and a lot of the math we're going to do, is not really difficult. It's really just learning the steps in what order to do what step in. And again, in this particular place, the only step was to eliminate what was attached to the letter, in this case the x. In order to do that, you were doing the opposite. So when we added, we used subtraction. When they were subtracting, we used adding. When they were multiplying, we used division. And when they were using division, we're using multiplication. So again, hopefully this will help. There'll be more videos with algebra. There'll actually be another video in this same Google Classroom slide dealing with fraction coefficients. So feel free to check that out when you get to it if you need any more help. Otherwise, I'm signing off. And again, hopefully this was helpful for all of you.